Hello and welcome. My name is Chris. My handle is Montevaca, and this is the fourth in my series of Unity 3D scripting tutorials. This tutorial is going to be focusing on creating orbiting bodies with Unity 3D's physics engine. We are going to largely focus on this one, trying to create multiple orbiting bodies around one single fixed Earth-like planet. This is a continuation of my previous tutorial, so I'm going to assume that you guys have already watched that and are up to that point. So let's get started. This is the scene I'm currently at is very similar to the previous scene that we had been working on. I've done a few changes just to start out. Textured the rotating moon that we're going to have sending around. I've also our Earth object, I've changed it to a body object instead of the Earth tag. Here, I'll change it. What we're going to do is we're going to have every actor in the scene, everyone that has gravity, is just going to be a generic body, and I'll show you how that works out in a moment. So the first thing we're going to want to do with this is we're going to want to come and create a empty object, and this will keep track of all the bodies in the scene for us. So we're just going to call this manager. And then we're going to create a new script. Create new C# script. And we're going to call it, come on, body manager. If I can actually spell. Okay, if we open this up, actually, here, we're just going to call it, already got that in there, body manager 2. Sorry. So body manager 2, body manager 2. And what we're going to do in the script is we're going to create a public variable, public game object, don't forget to capitalize the O, object, and this is going to be an array. We're going to call this body. Okay. Then we're going to create void awake. Don't forget to capitalize that as well. And then on awake we are going to set body equal to game object dot find game objects, so with an S, with tag body. Okay, so that'll fill up our array with every object in the scene that is tagged body. I'm also going to come down here and put it under update as well, just to, because we might be destroying some of those objects in the scene. So once we have that saved, we will come down here and attach the script to our manager script, our manager object. So we come down here and there's our body array. It's 0 at the moment. We have to fill it up on actual starting the simulation. But with that, we're going to now open up our orbiting script. This is the script that we had before. It's attached right now to our moon object. I've come in here and the only changes I've made is I've taken out stuff. So I've taken out the Earth target, since we're no longer having Earth, and I've also taken out where we set the Earth target. So, and then I've also just completely deleted the update, all the stuff in the update, because we are going to be changing that, kind of starting over from scratch, kind of not. So first things first, under update, now that we've got everything set, we're going to want to do game object, creating a game object, and we're just going to call this reference and this is going to equal to game object dot find game object with tag. We're going to be looking for manager. Oh, I forgot to tag our manager. So here, let's finish this and then we'll come back out. So I'm going to save this, and just so I don't forget for later, come out here. Our manager is untagged. I've already created a manager tag, so now it's tagged. Okay. And next on our list, we are going to create a for each loop. For each. And then we're going to for each game object, and we're just going to call them bod. In our reference object, and we're going to do get component. I'm actually just going to copy this from where I've got it written down earlier. Okay, so we're going to do a for each loop, which is game object bod in our reference game object. We're going to get the component body manager 2, which is our script, and from our script we're going to get our body array, and then we'll do this for each loop. So first thing in our for each loop, we're going to do vector 3 line. This is very similar to our last project, except instead of an earth variable, we are just doing it for each body variable. So transform dot position and minus moon dot position. There we go. And now we're going to do the distance calculation a little early, and I'll go into y in a second. So distance equals vector 3 dot capital D distance, and then it's going to be bod position, so copy paste, and moon position, control copy paste. There we go. Okay, and now we're going to do an if statement. If distance does not equal 0. This is why we calculated distance a little bit earlier than we did in the last project. It's because we wanted to make sure there's a chance that when we go through, well, there's a certainty that when we go through each body variable in the body array, we'll eventually come to the actual game object for the game object that this script is currently attached to. So we don't want to do any of these calculations or any of these force adding to it if we're comparing the object to itself. So we're just double checking that it's not itself. And hang on just a second. Okay, sorry about that. Back. Okay, so now that we're doing the test for the distance, inside as long as it's not the same variable, we're going to now normalize our line. Line dot normalize. Okay. And then once we've done that, we're going to add our force. So rigid body dot add force. And it's going to be, in here we are actually going to change up the calculation slightly from the last one to make it a little bit more realistic as far as the interactions between the bodies. So it's going to be line times, and then we're going to do this all in parentheses, body dot rigid body dot mass times rigid body dot mass times 9.81 F. So that's the two masses of the two objects that we are comparing, and the directional vector and the gravitational constant. And that's going to be all over distance times distance, or distance squared. And that should give us a much more accurate simulation of the gravitational pull of the objects. So if we save, we come out here. So we're missing something. Oh. Whoops. There we go. Save. And add force needs to be capital A. And that should work now. We run it. Is it working? No, it's not. So I'm going to pause real quick, figure out what's wrong, and then come back, okay?